Okay, I'm going to be covering a few problems that are similar to the ones on your homework. These are the evens, and I think the homework problems are the odds from the same section. So in this first problem, number 4, it says find the intercepts of xy equals 4, if there are any. That means that we have to find the places where xy equals 4 either crosses the x-axis or the y-axis. If it crosses the x-axis, that means the y-coordinate is 0. So you can plug in y to be 0 to find the x-axis intersections. So then you're left with x times 0 equals 4, which simplifies to 0 equals 4, which is obviously not true. That's a contradiction. So there are no x-intercepts. You can do the same thing with y-intercepts. X is going to be 0 if there's a y-intercept, so it's 0 times y equals 4. And that simplifies to 0 equals 4 again. So there's no y-intercepts, which means there's no intercepts at all. Okay, problem number 2 says check x to the 4th minus x squared plus 3 for symmetry with respect to both axes and the origin. That means we have to determine if it has x-axis symmetry, y-axis symmetry, or origin symmetry. To check for x-axis symmetry, you can replace y in the expression with negative y. So our expression is y equals x to the 4th minus x squared plus 3. To check for x-axis symmetry, you replace y with negative y, so it's negative y equals x to the 4th minus x squared plus 3. And then you can multiply both sides by negative 1 to get y equals negative x to the 4th plus x squared minus 3. And this expression right here is not the same as this one. So there's no x-axis symmetry. No x-axis symmetry. To check for y-axis symmetry, you do the same thing, except instead of replacing y, you replace x. So it would be y equals negative x to the 4th minus negative x squared. And make sure you put the replacement in parentheses, plus 3, which simplifies to negative 1 to the 4th times x to the 4th minus negative 1 squared times x squared plus 3, which is equal to 1 times x to the 4th, so x to the 4th, minus 1 times x squared, so x squared, plus 3, which is equal to the original expression, which means that there is y-axis symmetry. Now, you can tell right away that there's not going to be origin symmetry because there is x-axis symmetry, but there is y-axis symmetry, which means there's not origin symmetry. But to go ahead and explicitly check for it, you can replace both y with negative y and x with negative x, which will give you negative y equals negative x to the 4th minus negative x squared plus 3. And as we saw before, this whole thing on the right-hand side simplifies to the original, which is x to the 4th minus x squared plus 3. So we're left with negative y equals the original expression, which is not the same as y equals the original expression. So there's no origin symmetry here. Okay, so this question asks us to sketch a graph. This is going to be a parabola, 6x minus x squared. So for parabolas in general, you're going to want to plot points, just points throughout the axis. So you can make a table of x values and y values, and then you can plot the points and connect them with a line. Typically, you're going to want to plot the intercepts with the x-axis, the vertex, and 2 points on each side of every x-intercept. So to find the x-intercepts, you would set 6x minus x squared to 0, factor out the x, and you're left with x times 6 minus x equals 0, which means x equals 0, and then you're set with 6 minus x equals 0, so x equals 6. So the solutions to this are 0 and 6. So we're going to want to include that in the values that we include in the plot. So 0 and 6 will be our first values. Then the vertex will be at x equals negative b over 2a. If you have a general quadratic, it's ax squared plus bx plus c. So in this case, b is equal to 6, so it would be negative 6 divided by 2 times a, which is negative 1 in this case. So you're left with just, because you have to multiply by 2, so it would be negative 2, which is equal to 3. So 3 should be included in there. And then we just want values between the vertex and each intercept. So you can go with 1 and negative 1, for example, but it doesn't really matter. This is just to make it smooth. And then just like 2 other values, say 7 and 5. And then you compute the y value for each one of these coordinates. So 0 is going to be 0 because 6 times 0 minus 0 squared is 0. 6 also turns out to 0 because it's a root. The vertex 3 is going to evaluate to 9 because 6 times 3 plus or minus 3 squared is that's going to be 9. And 1 turns out to be 5 because 1 times 6 minus 1 squared is equal to 5. Negative 1 is negative 7, again because that's just plugging into this equation. 7 is negative 7 again because 6 times 7 is 42, minus 49 is negative 7. 6 times 5 is 30, minus 5 squared is going to be 5. So these are all the values that we need, and we can go ahead and plot these one at a time. So first 0, 0, then 6, 0, then 3, 9, so 3 over and 9 up. And note that the y-axis here is going in increments of 3 instead of 1. Then 1, 5. So 1 over up 5, that's about right here. Negative 1, negative 7, which is about right here. And 7, negative 7, so same y value as the last one, just as 7. And 5, 5. So right here. With all these points plotted, you can draw the line through them. I'm not going to do this well, but it doesn't really matter. And then just make sure you put an arrow on the end of both sides because it keeps going outside of the place where you drew it. And that's the end of this question. So number 14 is another sketching question. This one is a little bit easier though because it's just to transformation of the origin of one of the base graphs that you should know. So the base graph I'm talking about is just the absolute value of x, which the graph roughly looks like a V. So if that was the coordinate plane, absolute value of x is going to be like that. So this, what we're sketching here is the absolute value of x minus 4 minus 4. So from translation rules, we know that this is the same graph as absolute value of x, just shifted 4 units to the right and 4 units down. So if you go over here to the axis, well, I guess first you could solve for when it equals 0. So x minus 4 equals 0. Add 4 to both sides, you're left with x minus 4 equals 4. So when is x minus 4, the absolute value of x minus 4 equal to 4? Well, that's 0 because the absolute value of negative 4 is 4, so the solution set includes 0. And then 8, because 8 minus 4, the absolute value of that is 4 as well, so 8. That's when it crosses the x-axis. So you'll have a point at 0, 0 and 8, 0. And then you know that the bottom of the V here will be at 4, negative 4, because it's translated 4 units to the right, 4 units down. So that's right here. Now it's just going to be the lines between these points here, like this, and that keeps going, and then over here, the same thing. And that's the plot. Okay, so this wants us to, number 22 wants us to plot negative 7, 8 and negative 1, 8 and find the slope between those 2 points. So just first plotting them, negative 7, 8 would be halfway between these 2 check marks here and at 8 up. So right here. And then the other point, negative 1, 8, has the same y value, just at x equals negative 1. So there's the 2 points. So to find the slope between them, slope equals m equals the change in y over the change in x. So to plug that in here, the slope is equal to the y-coordinate of the first point minus the y-coordinate of the second point. So that's 8 minus 8 divided by the x-coordinate of the first point minus the x-coordinate of the second point. So negative 7 minus negative 1. It doesn't matter what the denominator is here because the numerator is 0, so the slope is 0, which means it's a constant, unchanging value. That's the answer though, m equals 0. And just to label these points, this is negative 7, 8 and negative 1, 8. Okay, number 28 is asking to find an equation of a line that passes through 5, 4 with a slope of 0. So if a line has slope 0, it means it's horizontal, parallel to the x-axis. So to sketch the line, all you have to do is plot 5, 4, which is right here, roughly right there. And just draw a horizontal line that passes through that point. And put the arrows. To find an equation of this, you would use the fact that you know the slope is 0. So the line's equation is some a special case of this formula right here, y equals mx plus b. That's the basic slope-intercept formula, and we know m equals 0 because m stands for slope. So, and we have y equals 4 because that's the y-coordinate of this point, 5, 4. And we have the x equals 5 because that's the x-coordinate of this point. So we can rewrite this 4 equals 0 times 5 plus b. And then simplify that, so 4 equals b, which means that the y-intercept is at 4, and the line equation is y equals 0x plus 4, or you could just write y equals 4. Okay, number 34. Sketch the graph of x squared minus y equals 0, and use the vertical line test to determine whether the equation expresses y as a function of x. So this is just another sketching problem. So we're going to do the same thing for sketching a parabola as before, except this one doesn't cross the x-axis. It touches it, so we don't need to plot points on both sides of the x-axis. We can just start a table of values here with x and y. So this is, well, first of all, x squared minus y equals 0 is the same thing as y equals x squared. You just add y to both sides to see that. So this is our function right here. So we know this is going to be, the vertex is going to be at the origin because this is the base square function. So 0 squared is 0. You can do negative 1 squared is 1. Negative 2 squared is 4. And just to do the other side, 1 squared equals 1, and 2 squared equals 4. So these are points again that we can plot. 0, 0, negative 1, 1, 1, 1, negative 2, 4, and 2, 4. Then just smoothly connect the dots like before, and you're going to be left with a parabola. Now the second part of the question says use the vertical line test to determine whether the equation expresses y as a function of x. So that means if you pass a vertical line over the function, it will not intersect the curve at more than one point at a time. So I just have this blue line right here. This is my vertical line. If you sweep the vertical line across the x-axis like this, notice how the blue and purple lines never intersect at more than one place at once, which means that this function does pass the vertical line test. So I'm just going to write that, passes vertical line test, which means it expresses y as a function of x. Okay, the last question, number 40. Given f of x equals 1 minus x squared and g of x equals 2x plus 1, evaluate each expression. So each of these following expressions, just substitute in the function definitions. F of x minus g of x. F of x is equal to 1 minus x squared, so this is 1 minus x squared minus g of x, which is 2x plus 1. And then simplify this. It's 1 minus x squared minus 2x minus 1, which is equal to negative x squared minus 2x. And that's the answer. F of x times g of x. F of x is equal to negative 1, or f of x is equal to 1 minus x squared. So put that. And times g of x, which is 2x plus 1. Here you're going to want a FOIL, which means first terms, outer terms, inner, and last. You multiply each pair of terms together. So first, 1 times 2 times x would be 2x, plus 1 times 1, which is 1, plus negative x squared times 2x, which is negative 2x cubed. And finally, negative x squared times 1, which is just x squared. And you can leave this as it is, because this is in the simplest form that it can take on. So this is the answer. And then we have g of f of x, which is the same thing as saying g composed with f of x. It just means that you pass in f of x to g of x as if it were a number. So g of x is equal to 2x plus 1. So it's 2 times something plus 1. And here the something is equal to f of x, which is 1 minus x squared. So simplifying this, it's 2 minus 2x squared plus 1, which is equal to 3 minus 2x squared. And there you go, that's the final answer. So hopefully these are helpful for your homework, and that is all.